There's a force applied. The disk is having a mass m, this particle. Both all are lying on smooth horizontal surface. Find the acceleration of the small body. Acceleration of small body means this m only, no? You mean to say here. So this is the rope. Huh? So some of you. These are very important. Please do think on such numericals, no? Oh, yeah. Let me get it. Let me get into this one. So I applied a force on this rope, no? So what is that force, no? I think that this will be better diagram for you. With what force I'll pull the rope, that will be the tension. I think this is a quite, it is like this. So this will move like this, acceleration. This will accelerate. This will be alpha 1. Anybody, can you say about tension? Will it be same or different? Very primary question I'm asking. Tension must be different. So instead, like a better write F. That will be more justified in the question. And F will not be equal to T. So how come? But you said tension should be same on either side of a pulley. It's having a mass M.
Friction will act now.
Did he say that? So that string does not slip over it. String wheel does not slip over means there'll be friction here. Okay, let's not bother. So therefore the tension must be different here. So therefore what force you pull, there'll be the tension here, and the tension in this part and this part will be different. So what is the motion now? So let's write what all possible motions now. Now for the disk, it will be F plus T equal to MA1, T equal to MA2, then F into R minus T into R should be equal to M R square by 2 into alpha 1. Straight away. So how many unknowns are there? Check it. A1, A2, alpha 1, T. Voice is breaking. Okay, F by 3M. F by 3M. Let me wait for answer. I don't have. I think I'm unable to somewhere answer. I didn't gather it. Okay, now after this. Any constant equation can we write for this? How accelerations are related? So I'll directly going to take help of this point P. A1 and A2 are labeled as in the diagram F plus T1, T equal to MA2. Okay. I'm doing correction. Thank you. Yeah. No. What's with there's a string, no? There's string. String is inextensible. So acceleration of point P should be equal to acceleration of this particle. APX should be equal to A2. What is APX? A1 minus R alpha 1. So what is our mindset? Where all two bodies are in contact, one constant equation, where all string is there, through the string we'll get a relation between accelerations. Then body is having translative motion, net force equal to ma. Body is having rotation motion, torque equal to I alpha. I think somehow we should fight with these ideas only, no? Now substitute all A1 equal to F plus T by M. R alpha 1 should be equal to 2 into F minus T by M should be equal to A2 will be T by M. Solving this, we'll get the T. R alpha 1 minus A1. Huh? Let me just think once constant equation. Acceleration of Px is towards left, no? So towards left means R alpha 1. Okay, okay, yeah. Let me rewrite. So R alpha 1 will be 2F minus T by M. A1 will be F plus T by M. So solving this, we'll get T in terms of F. Then we can calculate the acceleration. Anybody value A2?
F by 4m.
F by 4M. Small idea based. I think you give priority for such problems. There are Edo, there are 6 are there. In Esiorma, there are around, I think, some 3 are there. Again, you take the Stingage book, there are around 4 are there. Balaji publication, there are 4 are there. So like that, and Physics Galaxy, there are 3 are there. If you gather all, there are some around 15 questions are there based on just different idea. But the method is same. The different constraint equations, different rotational conditions will come into picture. Okay, I made corrections here. No, this is the I made correction here. No? Okay, now we'll stop the class here. So tomorrow, I think tomorrow we have all day. Huh? Anybody? Any information? Let me first finish off the class.